n equal to p1 power n1 into p2 power n2 into pr power n, where p1, p2, pr are distinct points. Then Zn is equivalent to Z p1 power n1, Z suffix n is equivalent to Z p1 power n1, p2 power n2, pr power n1. For example, 72 is equal to 8 into 9. 8 means 2 cube, 9 means 3 square. They are in the form p1 power n1, p2 power n2. So Z72 is equivalent to Z2 cube cross Z3 square, and also equivalent to Z3 square into Z. That is, it is equivalent to Z8 cross Z9 as well as Z9 cross Z8. Very important is Z72 is equivalent to, if you want you can write down that, you know that Z8 cross Z9 not equal to Z9 cross Z8. They are not equal, but equivalent. Equivalent means isomorphic. They are similar, not same. They are similar, but not same. So here you can see what is the no, take down this as no. Z72 is equivalent to Z8 cross Z9, which is also equivalent to Z9 cross Z8. But Z8 cross Z9, but Z8 cross Z9 not equal to, but Z8 cross Z9 not equal to Z9 cross Z8. Z8 cross Z9 not equal to Z9 cross Z8. They are equivalent. Z72 is equivalent to this. These two are isomorphic. These two are isomorphic. These two are isomorphic. Isomorphic is similar. They are similar, but you cannot say they are equal. You cannot say, because A cross B not equal to B cross C. Direct product is non-commutative in general. In particular, for some elements, it may be equal, but not in general. In general, direct product is non-commutative proof. Zm cross Zn not equal to Zn cross Zn. Up to this, is it clear, ma? Shall I have to explain anyway? Emma, is it clear for all of you? Shall I go to next?
Yes.
Charging.
Find orders of elements of Z.
Charging.
Z2 cross Z3 is non-abelian group of order 6, we know. What are the elements? We have seen. Identity is 0, 0. So what is the definition of a else order of
Charging.
by definition? Order of A cross is order of A, LCM of orders of the. We are asked to find orders of the elements. Every element order we are asked to find. What is order of any element? It's nothing but LCM of order of A in Z2, order of B in Z3. Because A belongs to Z2, B belongs to Z3. For finding order of A, we have to find order of A in Z2. Order of B, we have to find in Z2. Take else. Let us. So we want orders of each and every element. So we know that I'm trying to find out first for 0, 0. What is order of Z? Order of 0? 0 is there in this. It is under addition. So n into A. What is meant by order? If n into A is equal to E, what is identity? 0. Then if n is the least positive integer, that means the first positive integer for which n into A is E, then order of A is said to be n. So you know that for 0, 0 into 0 is 0, but order should be positive integer. So you have to start with 1. 1 into 0 is 0. You know 2 into 0 is also 0. 3 into 0 is also 0, but least is first, 1. So order of 0 is 1, which is R1. 0 belongs to Z3. This implies, here, we know, again, 1 into 0 is 0. So order of 0 is 1, which is R2. This is R1, this is R2. What is order of 0, comma 0? It is the LCM of R1 and R2. It is the LCM of 1, comma 1, which is 1. So order of 0, comma 0 is 1. Next, order of 0, comma 1, we have to find LCM of order of 0 in Z2, order of 1 in Z3. What is order of 0? Just now we found it is 1. So R1 is 1. Next, what is order of 1 in Z3? For 1, what is the order in Z3? 1 into 1 is 1, not 0. 2 into 1 is 2, not 0. 3 into 1. What is the 3 into 1? Operation is addition. Earlier we have discussed n dot a means a plus n times. Because the operation is addition, we cannot multiply. N into a has no meaning at all in modulo system. So n dot a means a plus a n times. Similarly, 3 into 1 means 1 plus 1 plus 1 under modulo 3. 1 plus 1 is 2, 2 plus 1 is 3. 3 when you divide by 3, remainder is 0. The order of 1 is 3, which is R2. Now take LCM. Order of 0, 1 is LCM of 1 and 3. Is 3. Next, order of 0, comma 2. Order of 0 is 1. What is order of 2? We have to find where in Z3. Second element means we have to find in Z3. First element means we have to find in Z2. 2. 1 into 2 is 2, which is not 0. 2 into 2 is 2 plus 2, which is 4, which is 1, not 0. 3 into 2. 2 plus 2 plus 2 under modulo 3, which is 0. So order of 2 is 3. Order of 2 is 2. Order of 2 is 3 in Z3. So what is the order of 0, comma 2? LCM of 1 and 3, which is 3 itself. Order of 1, comma 0. For 1, we have to find the order. 1 into 1 is 1, which is not 0. 2 into 1 is 1 plus 1 under modulo 2, which is 0. Because order of 1, we have to find in Z2. What is order of 1 in Z3? In Z3, order of 1, earlier we found order of 1. In Z3, it is 3. Because it is in second place, earlier we found in Z3. Here it is in first place. So we need to find out in the first place now. The order of 1 in Z2. So 1 into 1 is 1, not 0. 2 into 1 is 1 plus 1 under modulo 2, 0. Order of 1 is 2, which is R1. The order of 0 is 1, which is R2. So what is order of 1, comma 0? LCM of 1 and 2. What is the LCM of 1 and 2, which is 2? Somebody muted yourself. Homework. Extra homework. Order of 1, 0. LCM of 1 and 2, which is 2. Order of 1, comma 1. What is order of 1, comma 1? How to find out? You have to find order of 1 in Z2, order of 1 in Z3. In Z2, already we know order of 1 is 2, just now we have seen. In Z3, order of 1 is 3. So take LCM of 2 and 3, which is 6. Next, what is order of 1 in 2? Order of 1 in Z2, we already know it is 2. What is order of 2 in Z3? Second element means in Z3 is 3. Already we have done earlier. Now take LCM, which is 6. Next, 1, comma 1. So 1, comma 1 here, order of 1, comma 1 is 6, which is equal to order of Z2 cross Z3. What is order of Z2 cross Z3? 6. So if the order of the element, this is an element in Z2 cross Z3, this is an element. This is an element, 1, comma 1 is an element in Z2 cross Z3. And order of 1, comma 1 is 6. Order of 1, comma 1 is 6. Therefore, we can say that whenever an element, order of A is equal to G, we have studied in cyclic groups. If order of A is equal to order of G, then such a group is said to be cyclic, and such an element is what is called as the generator. Earlier we have studied. Is it not? So how to know which is the generator? Whichever element is having order which is equal to order of the group, that is what is called as the generator. If there is generator, such a group is what is called cyclic group. We know that Z2 is cyclic, Z3 is cyclic, but Z2 cross Z3 may be cyclic, may not be cyclic, but it is cyclic. Why it is cyclic? And what is the generator? Because there is an element 1 comma 1 whose order is equal to 6, which is order of Z2 cross Z3. Therefore, we say 1 comma 1 is generator of Z2 cross Z3. Therefore, Z2 cross Z3 is cyclic. So every individually G1 cyclic, G2 cyclic, then G1 cross G2 may be cyclic, may not be cyclic. You have to check. So how to check whether it is cyclic or not? We have to find a generator. How to know whether there is generator or not? We have to find out the order. If the order of the element is equal to order of the group, then we say that it is cyclic. Clear? So order of 1 comma 1 is 6, which is order of Z2 cross Z3. So 1 comma 1 is called generator and it is cyclic. Very, very.
Madam,
yes.
ఈ జనరేటర్ కాన్సెప్ట్ సార్ చెప్పరా ఇందులో ఈ డైరెక్ట్ ప్రోడక్ట్
Okay. Indirect product. You want in direct product or in the original?
cyclic groups here only.
Only here.
ఇక్కడ మేడం ఇక్కడ
Okay. So what is meant by this generator is, earlier we have seen, even though G1, G2 are cyclic, G1 cross G2 need not be cyclic. We stated. Then under what conditions they are cyclic? Whenever 2 and 3, what is the GCD between 2 and 3? 1, co-prime. Whenever the GCD between any two of them is 1, then in that case such a group is cyclic. For checking whether it is cyclic or not, you need not do all this. Just to see whether this 2 and 3 GCD is 1 or not. If GCD between 2 and 3 is 1 and individually G1 is cyclic, G2 is cyclic, then G1 cross G2 is also cyclic. Earlier we stated that. Zm cross Zn is cyclic if and only if M and N co-prime, they are co-prime. What is meant by cyclic? There should be a generator. What is meant by generator here? In Z2 cross Z3, what is meant by generator is every element X belonging to Z2 cross Z3, we should be able to express as N into A comma B. What is N? Positive integer. If we are able to express every element, then we call such an element A comma B as generator and such a group as cyclic. But here we already know it is cyclic because 2 and 3 GCD is 1. But we want what is generator. What is the generator of this? The element whose order is equal to order of this is the generator. So we got 1 comma 1 as generator. You want to know what is generator here? What is the property it satisfies? So, for example, 1 comma 1 is generator. That means every element of Z2 cross Z3, we should be able to express in terms of 1 comma 1. We are able to do for every element what is an positive integer. Then we say it is a cyclic group. Let us discuss. 0 comma 0. This is an element in Z2 cross Z3. What are the elements of Z2 cross Z3? We have seen Z2 cross Z3 elements are 0, 0, 0, 1, 1, 0, 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1. Let us see. 0, comma 0. Let us see. 0, comma 0, can we write it as N into 1, comma 1 or? So, 0, comma 0, can we write it as N into 1, comma? It should be the positive. What is meant by N into 1, comma 1? 1, comma 1 plus 1, comma 1 plus 1, comma 1 and so on. So, if you take 1 into 1, comma 1, it is 1, comma 1, which is not 0, comma 0. 2, comma 2, 2 into 1, comma 2. What is meant by 2 into 1, comma 2? 2, comma 2. Because 1 plus 1, 1 plus 1. which is not equal to 0 comma 0. Which is not equal to 0 comma 0. Next. Like this, if you do 3 into that, no. 4 into that, no. You will get for 6. 6 into 1 comma 1 will be equal to 6 comma 6. If it is 5 into 1 comma 1, 5 comma 5, which is not 0 comma 0. 6 comma 6 means 6 comma 6. You know that 6 is 0 under in Z2. Why it is 0 under Z2? Because this is divisible by 2. 2 divided by 6 divided by 2, remainder is 0. This is under Z3. 6 when you divide by 3, remainder is 0. So when it is 2 more than 2, we have to divide by 2. If this is 3 or more than 3, we have to divide by 3 and write them. So this is 0 comma 0. Next, we have to see 0 comma 1. So we are able to write 0 comma 0 as 6 into 1 comma 1. Now let us check with 0 comma 1. Can we write it as n into 1 comma 1 or? We have to check. So let us start with 1. 1 into 1 comma 1 is 1 comma 1, which is not equal to 0 0. 2 into 1 comma 1. 2 into 1 comma 1. If I take 2 into 1 comma 1, what is the element we have taken? 0 1. Remember what is the element we are trying to test? 0 1. Is it equal to n into 1 1 or no? We have to check. So let us take n equal to 2. 2 into 1 1. That is 2 comma 2, because 1 comma 1 plus 1 comma 1. Because it is MCQ, I am escaping. 1 plus 1 under modulo 2, 1 plus 1 under modulo 3. 1 plus 1 is 2, 2 under modulo 2 is 0. 2 under modulo 3 is 2, which is 2 into 1 1 is 0 2. In Z2 comma Z3, is 0 comma 2 there? In Z2 cross Z3, is Z2 cross
Yes,
Z3?
0 comma 2 is there.
0 comma 2 is there. Yeah. So 0 comma 2 we can write in terms of, we are able to write in terms of 1 1. So 0 comma 2 is 2 into 1 1. 0 comma 0 is 6 into 1 comma 1. These two we have completed. 0 0 we have completed. 0 2 we have completed. Let us see. 3 into 1 1. What is 3 into 1 1? 3 comma 3. What is 3 into 1 1? 3 comma 3. What is 3 comma 3 is? Because 1 comma 1, 1 comma 1, 1 comma 1. Add 3 times. So directly I am writing 3 comma 1. 3 into 1 comma 1 is 3 comma 3. What is 3 under modulo 2? 3 when you divide by 2, remainder is 1. 3 when you divide by 3, remainder is 0. So we are able to write 1 comma 0 as 3 into 1 comma 1. So we could write 0 0, we could write 0 2, we could write 1 1. Next, 4 into 1 1. If you take 4 into 1 1, 4 comma 4. What is 4 under modulo 2? First element is in Z2. Z2 means what? If it is 2 or more than 2, you have to divide by 2 and get remainder. So 4 when you divide by 2, remainder is 0. This is in Z3, second element. 4 when you divide by 3, what is the remainder is 1. 4 divided by 3, 3 ones are 3, remainder 1. So 0 comma 1, we are able to write it as 4 into 1 comma. So we could write 0 1. 4 elements got completed. Now let us write 5 into 1 comma. What is 5 into 1 comma 1? You can write 5 into 1 comma 1 as 5 comma 5. 5 comma 5. What is 5 under modulo 2? When you divide 5 by 2, 2 2s are 4, remainder 1. 5 when you divide by 3, 3 ones are 3, remainder is 2, 1 comma 2. So we are able to write 1 comma 2 as 4 into 1 comma 1. Now only thing left over is 1 comma 1. 1 comma 1 can be written as 1 into 1 comma 1. So we are able to write every element as n into a. What is a? 1 comma 1. So 1 comma 1 is what is called as a generator. Is it clear now? Original definition. So we are able to write every element of Zm cross Zn, that is 0 comma 0, as n in 1 into 6 into 1 comma 1. We could write 0 comma 1 as 3, that is 2 into 1 comma 1. No, not 2 into 1 comma 1. 0 comma 1, what did you get? 4 comma 5. We got 4 comma 4. So 4 into 1 comma 1. We got this is 4, this is 4 is 1. So we could write every element as multiple of 1 comma 1. Therefore, we can say that 1 comma 1 is a generator. Whenever there is a generator, such a group is what is called cyclic. This much we have to do. But what I am saying is, if there is an element whose order is equal to order of the group, that itself is automatically a generator. What is order of 1 comma 1? We have seen order of 1 is 2, order of 1 is 3, LCM is 6, so order of 1 comma 1 is 6. Therefore, 1 comma 1 is generator. Did I answer your question? So Z2 cross Z3 cyclic. Emma, did I answer your question? Yeah.
Clear, ma'am.
Huh? Clear,
Ma'am,
no?
here 1 comma 2 is also a generator, no ma'am?
There can be more than one generator.
Okay, ma'am.
You can find at least one generator sufficient.
Okay, ma'am.
1 comma 2, what is the order?
6, ma'am.
So that is also a generator.
Okay, ma'am.
So any element which is of order equal to order of the group is a generator. We know that for a cyclic group there can be more than one generator. Did you attend that class, ma? Abstract algebra 1? Taranya, who asked this doubt?
Saranya, ma'am. Yes, ma'am, I attended, ma'am.
Yeah. Then we have discussed there. Whenever
Yes,
A
ma'am.
is a generator, then A power M is also a generator, provided A power N is a generator, provided M and N are relatively prime. Do you remember?
Yes, ma'am. Yes,
There
ma'am.
are 5 N generators. Generator need not be unique.
Okay, ma'am. Thank
That's
you,
what we
ma'am.
have said. If it is infinite, only 2 generators, namely A and A.
A and A inverse. Yes, ma'am.
Same thing holds good here also. But the G1 cyclic, G2 cyclic, then G1 cross G2 need not be cyclic. Need not be cyclic. Want you can note down that point. Write down this as a point. If G1, G2, Gn are cyclic, note down this point. If G1, comma, G2, comma, and so on to Gn is are cyclic groups, then G1 cross, G2 cross, and so on up to Gn need not be cyclic. G1 cross, G2 cross, and so on up to Gn need not be cyclic. Need not be means maybe, may not be. So what are G1, G2, Gn? They can be any groups. But if they happen to be Zn, then they are cyclic. If and only if the GCD between the suffixes is small. Write down that point. If GCD between Mi and Mj is 1 for all I not equal to j, then Zm1 cross Zm2 cross and so on Zmn is cyclic. If Mi and comma Mj, what is meant by this bracket? Bracket means GCD. Square bracket means LCM, open bracket means GCD. If the GCD between any two pairs is 1, not only adjacent, every pair, then for all I not equal to j, then Zm1 cross Zm2 cross Zmn Zm1 cross Zm2 cross and son up to Zmn is cyclic.
Okay.
Okay, next one. All of you, is it clear? So in general, not cyclic, but cyclic only if there is generator. How to identify generator? Don't do all this. Find out the orders of the elements. If there is an element whose order equal to order of the group, then that becomes a generator. If there is at least one generator, it is cyclic. Otherwise, in general, no. Here, without doing all this, we can conclude it is cyclic. Why? Because 2 and 3 GCD is 1. So Z2 cross Z3 is cyclic because Z2 is cyclic, Z3 is cyclic. The generator for this is 0, the generator for this is 0. Because you know Zn is cyclic with a generator as 0. Is it not? Is the generator, sorry, generator as 1. I'm sorry, generator is 1. In general, write down that point. In general, Zn plus n is cyclic. Zn plus n is cyclic with a generator. With the generator as 1. With the generator as 1. Is under addition. 0 is the identity, 1 is the generator. So now for Z2 generator is 1, for Z3 generator is 1. Now for Z2 cross Z3, 1 comma 1 is the generator. Not only this, 1 comma 2 is also a generator. 2, why? Because LCM of 2 and 3 is 1. Order of 1 comma 2 is also 6. Order of 1 comma 1 is also 6, which is equal to order of the group. So 1 comma 2 is also a generator. 1 comma 1 is also a generator. You know that generator is not unique. There can be more than one generator. You are asked to get what is the generator, then only you need to proceed. Otherwise, by looking at this itself, you can conclude whether it is cyclic or not. For example, Z2 cross Z4, it is not cyclic. Why? Because 2 and 4 GCD is not 1, it is 2. So if they cannot be cyclic, that means there is no generator for them. You know Z2 is cyclic, you know Z4 is cyclic, but Z2 cross Z4 is not cyclic because there is no element whose order is equal to order of the group. If you want, you can try after going to that place. And moreover, GCD between 2 and 4 is 2, which is not 1. If the GCD between any two of them is 1, then only we say it is cyclic. Next, Zm cross Zn not equal to Zn cross Zm. So this is non-abelian group. Number of subgroups of Zn. Earlier we have studied, in the beginning also I told you, Zn plus n is a group. Then how many subgroups it will have? What is a subgroup? Yes, a subset of a group which is also a group is called subgroup. So how many subgroups this will have? We want to know how many subgroups are there. So how to know? There is one shortcut. Number of subgroups of Zn is equal to tau n. What is meant by tau n? Number of divisors of n. How to find number of divisors? Earlier we have discussed. What is tau n? Number of divisors. How to get number of divisors? Express n as p1 power k1,
Charging.
p2 power k2, and so on, pk power kr. then tau n is equal to powers you have to take k1 plus 1. What are p1, p2, pn? They're all primes. k2 plus 1 and so on. kr plus 1. k1 plus 1, k2 plus 1 and so on to kr. Order of G, 2 cube into 3 power 4, which is M. Number of subgroups is equal to tau n. That is tau of 2 cube into 3 power 4. What is the formula? 3 plus 1 into 4 plus 1. So how many?
Charging.
20 subgroups are there for the group of this order. What is the order of the group? 8 into 81. That is the order of the group. So if the order of the group is given, if the group is abelian, this formula is applicable for all abelian groups. If the group is abelian, where G is abelian, then if the G is abelian should be given here. If G is abelian, then number of subgroups is equal to tau n. That is power plus 1, power plus 1. Otherwise, we cannot apply. If it is non-abelian group, we cannot apply this formula. This formula, number of subgroups of Zn, order n, can be applicable for any group which is abelian and is of order n. What is the order of G? 2 cube into 3 power 4. And the G is abelian. Then number of subgroups is equal to tau n. Tau of 2 cube into 3 power 4. So 3 plus 1 into 4 plus 1. Is 4 into 5, which is 20. What is the order of Z12? N equal to 12. Number of subgroups, tau n. That is tau of 12. How to write 12? 2 square into 3 power 1. Power 2 plus 1, 1 plus 1. 3 into 2, which is 6. Next, order of Z2 cross Z3, it is 6, which is N. And number of subgroups is equal to tau 6, which is tau of 2 power 1. So 1 plus 1, 1 plus 1, which is 2 into 2.